Hello viewers, today's question is on logarithmic equation. So in this logarithmic equation, I'm going to walk you through the process of obtaining the value of theta, okay, the angle theta, okay. So stay with me to the end of this video, and if you find value, please consider subscribing. So let us dive into the question right now. Alright viewers, the first thing I want you to remember are some expressions for trig functions. Remember that tan theta can also be written as sine theta over cos theta, and of course remember cos theta, which is the inverse of tan theta, can also be written as cos theta over sine theta. So with this expression for this trigonometric function, we are going to substitute these guys into this equation. So I have it to be log cos theta can also be written as cos theta over sine theta, okay, then to the base sine theta, then plus we have log tan theta can also be written as sine theta upon cos theta to the base cos theta, all equal to 0. Now also remember some laws of logarithm that says if you have log a upon b, you can write this as log a minus log b. And don't forget that log a base a is 1, okay? So let us apply this law to this logarithmic equation. So from here I'm going to have log cos theta sine base sine theta minus log sine theta as base, plus we have it to be log sine theta base cos theta minus log cos theta all equal to 0. I just split all these guys from this law, okay? That's exactly what I'm doing right here. Now remember that cos theta, this guy is going to become 1 and this guy is going to become 1. So from here I have log cos theta sine theta, here is minus 1, plus log sine theta cos theta minus 1 equal to 0. Okay, so let me take off these guys from here. Alright, now I want to do something from this point. Okay, so here is going to become log cos theta sine theta plus log sine theta cos theta minus 2 equal to 0. So taking the minus 1 together, we got minus 2 right here. So at this point, I'm going to change the base here. Remember how to change the base of a logarithm. If you have log a base b, for instance, I want to change the base to c. It can become log a base c upon log b base c. This is how to change the logarithm base, okay? So that's what I'm going to do right here. I want to change the base of this guy to be sine theta. So from here now I have log cos theta sine theta, okay, plus log, here it is sine theta over base sine theta all upon log cos theta sine theta. Okay, I've just changed the base of this logarithmic expression to sine theta, no longer cos theta. That is exactly what I just showed us right here. So of course we have minus 2 equal to 0. Okay, now at this point you want to simplify out. I want to say let's log cos theta sine theta be equal to p. Okay, so whenever I see this guy, I represent it as p. So this guy becomes p plus, of course, sine theta will give me 1 upon p. This guy is p, okay? Then minus 2 equal to 0. Now at this point, you want to multiply both sides by p to get rid of this denominator. So you have p times p will give me p squared plus 1 minus 2p equal to 0. And from here you have p squared minus 2p plus 1 equal to 0. Now we've gotten a quadratic equation, and we'll solve this quadratic equation by factorization method. So let me take all these guys from here. Okay. Okay, so we have p squared minus 2p plus 1 is equal to 0. Now at this point, we're looking for two values such that when you multiply them together, you get positive 1, and when you add them, you get -2. The two values are just -1 and -1. Okay, so that means this guy is going to become p minus 1 all squared is equal to 0. Okay, so at this point, you can say p minus 1 is equal to 0. Okay, when you take the square root of both sides like this, so you have this guy 0, and of course p is equal to 1. Okay, that's the value of p. P is positive right now. But you recall this statement. You recall that log cos theta sin theta is equal to p, and now the p is just 1. So from this point, you transform this logarithmic equation to an exponential equation. So you have cos theta is equal to sin theta to this 1 power. Okay, I hope we are moving. All right, so at this point now we have cos theta is equal to sin theta, or you can say sin theta is equal to cos theta. Now I want to divide both sides by cos theta. I will divide here by cos theta. I will divide here by cos theta. Okay, so here we have tan theta, because this is the same thing as tan theta, equal to 1. And from here you can say theta is equal to the tan inverse of 1. And of course the tan inverse of 1 is pi over 4, or you call it 45 degrees. Here is in radian. Okay, so this is the value of theta for the first quadrant. Then of course you know tan is also positive in the third quadrant, so for that one you can say theta also is equal to pi plus the reference angle, which is pi over 4. Okay, or for this other one you can say 180 plus 45 degrees. Okay, for this one we also have 225 degrees, and for this one we have theta is equal to 5 pi over 4. So these are the value of theta that will satisfy the given logarithmic equation we are solving for when theta is ranging from 0 degree to 360 degree. Okay, if theta ranges from 0 degrees to 360 degrees, or 0 degrees to 2 pi in radian. Okay, so this is the value of theta for this solution. I hope this is clear, viewers. I hope this is clear. If you find any question or you want any further explanation, please put it down in the comment section. And if you find value from this video, please comment and subscribe. Have a nice day and God bless you.